Okay, friends, welcome to NG Academy. Today, our topic of discussion is image formed by concave lens. Unlike concave lens, sorry, unlike convex lens, it has only two ray diagrams. At first, we place object at infinity and investigate its ray diagram. Next, we place object somewhere between infinity and focus of the lens. Before we move into our topic, we need to know the basics of concave lens. First, you need to know is the rules of refraction for concave lens. So there are some sets of rules of refraction through concave lens. Rules. So let's write here rules. So rule number first. So what is the rule number first? A ray of light coming from object. So let's draw. This one is concave lens. This is the rough ray diagram. I haven't used any kind of scale or pencil over here. So this is optical center O. Now what we have in rule number first, a ray of light coming from object. For example, this is our object located at infinite distance. So when the object is considered to be at infinite distance, then we assume the parallel rays of light are emerging from it. These are the parallel rays of light. These are the parallel rays of light emerging from the object. So what happens when the parallel rays of light is incident on a lens, then it diverges the light rays. It diverges the light rays. So this diverse light rays appears to come from this focus. This diverse light rays appears to come from this focus F. Our next rule number second. Rule number second, if this is your concave lens, diverging lens, a ray of light, this is focus, let's draw focus first, a ray of light appearing to pass through focus, ray of light appearing to pass through focus will emerge parallel to principal axis after refraction through the lens. This is rule number 2. Now let's check rule number 3. Rule number 3. Let's make concave lens first. This is the principal axis, this is optical center of focus of the lens. So what rule number 3 says? A ray of light passing through optical center of a concave lens will emerge without deviation. A ray of light passing through optical center emerges without deviation. There is no any kind of deviation here in this ray of light. Now let's see our topic of discussion. So image formed by concave lens when the object lies at infinity. So let's check it. First of all, let's measure 2 centimeter. Okay, today I will measure 3 centimeter because the lens is quite bigger today. Okay, let's mark 3 centimeter on either side. 1, 2, 3. 3 centimeters from the optical center on either side of the lens. Let's give name to this point. This is focus. This is focus. As this is as this is equiconcave lens, that's why its first focus and second focus are same. So what is our first condition, friend? When the object lies at infinity, so the light rays comes parallel to the principal axis. Light rays coming parallel to the principal axis first half and second half, I will take only two light rays, couple of light rays. These are the incident light rays. So what happens is that it gets diverged. It gets diverged after refraction through the lens. This is the rule. And these diverged light rays appear to come from this focus. These are the diverged. Okay. Now next. Again diverged, and this diverged light ray appear to come from this point called focus. Okay friends, now let's see the properties of image formed. Now at first what we see is the nature. The nature of the image is virtual and upright. Here the image is formed at the focus, and the thus formed image is virtual. virtual virtual image is formed, and the orientation of the image is upright. Virtual and upright. Okay, now next, so what is the size? Size matters. Point sized. Okay, the image, the thus formed image, the image is formed here, and the size of the image will be point sized. You have to write point sized. Now next, the position. So where is the image located? Position. The position is at focus. The image is formed at focus because these two light rays, the diverged light rays, appear to meet at this point called focus. So the image is formed at focus. So this is all about the image formed by concave lens when the object lies at infinity. Now let's move into our next point, that is number B, when the object lies between focus and infinity. Let's make focus first. Measure 3 cm on either side of the concave lens from the optical center. Mark at 3 centimeter, 1 2 3 from the optical center. This is your focus. This is your focus. Let's take object somewhere around focus and infinity. For example, this is infinite distance. For example, this is your infinite distance. I will show you here. This is your infinite distance. This is your infinite distance, and we will take here the object somewhere between focus and the infinity. So today I will take height of object to be 2 centimeter from the principal axis. Now let's follow rule number 1. What our rule number 1 says? Light rays coming from the object parallel to principal axis strike the lens. It gets diverged after refraction because concave lens has tendency to diverge the light rays falling into it. The light rays move in this direction, and the diverged light rays, these diverged light rays appear to come from this focus, and we take another light ray emerging from the object and passing through optical center. This is your optical center. Light rays emerging from the top of the object, and see here this virtual light rays dot light rays and this real light ray intersect in between focus and optical center. image is formed at the point of intersection between these two light rays. This is your image. Friends, your image here will be dotted lines. I again make this real. This is, in fact, this should be like this. Okay, just make you just make here should be, please replace this arrow with your dotted line. Make here dotted line, dotted image, because this is virtual. So now let's discuss the properties of image. So now the nature of the image formed is virtual. This is virtual image. Okay, virtual image, because this, why the image is called virtual, because this cannot be projected on the screen, and the image is upright. See the orientation, this is your object, this is your object, and the image, this is your image. The image and object are of same orientation, so this is upright. Now let's discuss about the size. So what would be the size? The size of the image is smaller than the size of the object, smaller than object. So what is the position of the image here? The position is, it lies in between F and O, lies in between focus and optical center. Optical center. So always students, always the image for concave lens lies in between focus and object. Wherever your object lies, it does not matter, this image always lies at focus and optical center. Wherever the object lies, it does not matter. You can place your object anywhere in between infinity and focus, but your image always lies in between focus and optical center. So let's discuss about its use. I use spectacle. My spectacle consists of concave lens. Concave lens helps us to see the distant object clearer. Friends, I hope you have understood what we have discussed today. If you have any kind of confusion, then you can mention in the comment section below. Stay healthy, stay well, and be happy always. We will meet in our another video. Till then, goodbye.